Hey guys, welcome back to Carly's channel.
Hey guys, it's Carly Camarillo, and today I will be informing you on the chemistry behind photography. First off, let's learn a little about the camera. The camera contains glass, plastic, metal, and wood. On the front of a camera lens, there is a glass lens that focuses into the camera body and onto the film. Inside the lens body, there are several optical lenses that further refine the image. These lenses are sometimes called elements. You get it? Elements? Chemistry? Anyways, the film has 4 layers. The first layer, which is called the protective layer, protects the second layer. The second layer, the emulsion, that has gelatin and silver crystals that make light sensitive. The third layer is the film base, a polymer which is chemically flexible and stable. The fourth layer is an anti-halation backing, which keeps the light from reflecting on the back of the film.
Fun fact numero uno. Yeah, I'm bilingual. In the year 1885, the use of photographic film was pioneered by George Eastman.
Fun fact about Dose. In the year 1888, the first camera, which is called the Kodak, went up for sale. So Benna!
Now on to the fun part, learning about the chemistry behind the process of the photos being developed. Photos are to be developed in a dark room. Through this process, we are going to basically project the film onto a large sheet of light-sensitive paper. This sheet is burnt by the light and put through a series of chemicals to fully develop the photo. Developing film and photos has a similar process. They have to go through 3 different chemicals. The first is the developer, which is a chemical consisting of paraphenylene diamine, which is used to develop the film. When the film is added to this color developing bath, the paraphenylene diamine exposes not only the film's silver halides, but also which are called diculper, which are chemicals in the film itself that are made of different colors. Next is the stop bath. A stop bath, which is typically a dilute solution of acidic or citric acid, or halts the action of the developer. A rinse with clean water may be substituted. The fixer makes the image permanent and light resistant by dissolving the remaining silver halides. A common fixer is hypo, specifically ammonium thiosulfate. Last is the fixer. Without fixing, the remaining silver halides would darken and cause fogging of the image. Fixation is commonly achieved by treating the film or paper with a solution of thiosulfate salt. Popular salts are sodium thiosulfate, which are also called hypo, and ammonium thiosulfate, which are commonly used in a modern rapid fixer formula. The main chemistry that goes on behind photography takes place in the emulsion layer. The suspended silver halide crystals, or crystalline and cubic in structure, contain silver ions and halide ions, which in this case are bromide ions, as well as sensitivity specks, which are impurities such as silver sulfide. Impurities trap light energy. When the photons from the light hit the grains, an electron is ejected from the bromine ion, causing it to become oxidized. The free electron moves around the crystal until it reaches a sensitivity spec. The electron can now combine with the silver ion, reducing it to produce metallic silver, which causes it to be colorful. This process occurs in the latent image center.
Panda. I got broads in Atlanta. Just took the lean in the family. Credit cards and the scammers.
Number 5. The first color photograph was taken in the year of 1861. Oh.
Fun fact number 4. Potassium chloride and aluminum made the first flash, which is basically a mini explosion.
The oldest surviving image is 200 years old.
The most expensive photograph is sold for $6.5 million.
Hey guys, I'm back. Photographic film and paper are made up of photosensitive grains of silver and halides. These grains react with light to create a latent image invisible to the eye. The halides that are often used are chlorine, iodine, and bromine. These silver halide grains are crystalline structures of silver ions. Grains are held by bonds and are very stable, but there are some movement. Next, you pour the required amount of fixer into the tank to remove the solar halide crystals from the film, or fixed image. Fixer is a much less temperature and time sensitive than the developer, and will prove usable at most temperatures from roughly 10 degrees Celsius, which is 50 degrees Fahrenheit, through to 30 degrees Celsius, which is 86 degrees Fahrenheit. You may now hang your photos until it dries. Thank you so much for listening to my presentation. I know you're sad it's over, but I hope you enjoyed watching the chemistry behind photography. Peace.